Hello everyone, and thank you for joining our MCube 5.4 launch webinar. My name is Andy Digelman. I'm the Chief Product Officer at TCG Digital. I'm very excited and extremely proud to lead you through our webinar. We have a packed agenda for you, where we have prioritized showing our platform in action over presenting slides. We have two additional distinguished speakers. Sargam Kalia, at the center of the screen, Product Manager for Low-Code Agentic Application Development, who will lead us through a supply chain operations example, where Gen AI and orchestrated agents become partners to plant heads and maintenance leaders when they are managing their supply chain. Our second speaker is Ashutosh Ranjan. He runs our Global AI Competency Center, where he brings Gen AI and agentic technologies to life with our customers. He will deeply dive into an advanced agentic application which leverages knowledge graphs, large language models, and advanced analytical tools to shorten the way to formulations. Before we dive into MCube 5.4, I'll hand over to Devdas Sen, our CEO here at TCG Digital, who will set the business context in which we will showcase our latest technology advancements. Over to you, Devdas.
Hello and welcome to this very important launch of MCube 5.4. It is always so wonderful to see all of you in this call joining from all around the world. Many of you are clients. We have some partners as well as several collaborators in this call. Just lovely to see you. And for our clients, thank you so much for your business. We live in unprecedented times. There are several parts of the world where there is wars raging. It is sad to see that many of our clients have got hit during the present crisis. I want to make sure that I'm able to communicate that we are with you as you go through these difficult times. And we hope that things will stabilize and we will get to see the era of AI move forward. And that is what we are here for. For example, we had a launch of 5.4 version from OpenAI, and we had a lovely launch from Claude a little while back. What we do at TCG Digital is to be able to take the best that's there in the external world, in the ecosystem, and be able to make it relevant for you in your enterprise. That's what MCube does. It takes your private data, it uses the strength of the large language models that are there around, and is able to solve complex problems for you. And that's what we've been focused on. I don't want to take the steam out of the next set of speakers. Andy Digelman, our Chief Product Officer, Ashutosh, who's our AI competency leader, they'll talk to you about how we are optimizing operations and how we are accelerating R&D. In today's day and age, it is very critical to make sure that the assets that we have around, large assets, petrochemical plants, refineries, large manufacturing units in pharma, steel, etc., or even critical infrastructure for the country, how do we sweat that more to get a higher efficiency out of that? At the same time, we make sure that we run them reliably so that there is no unplanned maintenance required. So that's one focus. And we'll hear a lot about that from our next set of speakers in the next 1 hour, whether it's pharma manufacturing, whether it's refining, whether it's petrochemicals, and that sector is going through a downturn right now. So it's important to make sure that we operate efficiently. Or it's in the area of R&D. How do we use AI to come out with new materials? How do we use AI to come out with new designs? And we're doing this in several sectors, particularly in life sciences and in what we call energy and materials, and seeing fantastic results in the area of formulation of new materials, as I said, as well as just quickening the process of R&D. MCube today is an ecosystem player, an ecosystem that is running at a breathneck speed in the world of inference, in the world of large language models that are just going so fast, improving the reasoning capabilities and so on, and makes that contextual to your organization. So sit back, relax, as they say, because aviation is also a very important sector for us, and hear about where we are on this. We are really excited to bring you MCube 5.4.
Thank you, Debdas, for sharing our vision. It's quite amazing how time flies in the generative world. Just a few months ago, we launched MCube 5.3, featuring the integration of Gen AI into our platform, extending our AI workbench into the world of generative AI and agentic applications. With MCube 5.4, we established generative and agentic applications as core to the way we move forward. The agentic core allows to create, publish, and manage agents, orchestrate agentic workflows, and creation of A2A and MCP servers. From spawning up agent servers, placing an agentic node on the canvas, selecting the appropriate framework, might be ADK or LangGraph, to configuring the agent sub-workflows. These workflows leverage a variety of private and public LLMs. Tool nodes allow to connect to local or remote MCP servers to leverage data and information in databases and other storage facilities, and classic machine learning, deep learning, or optimization algorithms. The finished agents are registered and published so they can be accessed via URLs and consumed by end users or other agents from within MCube or from the broader ecosystem. As MCube is designed from the ground up for enterprise class applications, we continue to expand our capabilities to ease the way to production for this new class of agentic applications. The new observability module Vortex provides transparency to manage MCube and its applications in production. Agentic interactions integrate seamlessly with our low-code development environment EasyExtend to master complex applications with ease. Our data integration module Morphex makes sure enterprise and public data are agent-ready. Workflow orchestration across and beyond MCube allows for connected workflows, and last but not least, leveraging enterprise-class identity management systems like Okta or Entra ID provide efficient single sign-on experiences for end users and administrators. We also added a vault to ease the management of secrets across the ever-expanding platform. Let's now move to software and solutions in action. As I have promised at the beginning of this event, we will see how it looks like when intelligence is embedded directly into a workflow, how we are moving from detecting risks to recommending structured actions. Over to you, Sargam. Let's dive into the world of supply chain operations.
Thank you, Andy. Hi, everyone. We are looking at the Agentic Command Center demo here. And here we are considering an electronics goods manufacturing company. And we all know for manufacturers, supply chains are constantly under pressure because demand fluctuates, suppliers face disruptions, and production always depends on the timely availability of raw materials. So the agentic command center brings all of this together into a single interface layer, allowing leaders to detect risk early, understand why it is happening, simulate different options, and take the required actions in time. So we start off with this screen, which is the command center dashboard. And when a supply chain leader would open the agentic command center, they would immediately want to see the health of their operations, which is what we are seeing here on the screen. So this dashboard consolidates inventory level, inventory levels and consumption trends, the different demand signals from confirmed sales orders, supplier reliability indicators, and AI generated stockout predictions. So instead of simply reporting what has already happened, the platform identifies potential disruptions before they impact production or revenue. For example, here we can see a stockout alert predicted for one of the products, which is about to get depleted in the next 3 days. So this is a critical component for the system, and MCube has detected this upcoming demand and supplier trends, based on which it has detected that there will be a shortage of this product, and within it gives you a window of 3 days to actually start taking action. So we don't need to wait till 3 days later and identify the problem, and rather we can just start work on it right away. Next, so this is what is contained in the system. Now let's quickly explore how we are getting to this. What are driving these alerts? So in the supplier intelligence view over here, we see that each supplier is evaluated using a dynamic risk score, which is derived from delivery performance, quality metrics, and lead time variability. And because this logic is defined in the semantic layer, the same definitions are consistently applied across dashboards, AI models, and operational workflows. So this ensures the data is always consistently evaluated across the platform. As we can see over here, all the different suppliers have a different risk score. Now we can select a combination of this. So this is the scenario simulation part, where we can actually decide, based on the different combinations of suppliers, what is the ideal combination for me to go ahead with. So I have selected one supplier as my primary supplier, and the other can be a secondary with a 70-30 division of the raw materials. And this is the impact summary that the system has provided me, which says that both the suppliers have a risk score of so and so, but it is a recommended combination for me because of the 98% relative cost index. So we can actually go ahead with. So the system is approving this combination, and the decision maker can actually go ahead with this. Next, we move to the reliability AI part, which is kind of the key of this entire exercise we are doing. Up until now, we had been predicting what has actually happened in the system. Here on, we are saying how we can better these changes, how we can mitigate those challenges. So this is the dashboard where we see what is the health of the system and what are some critical action areas that we need to start work on immediately. For example, we see this first critical alert which says that the assembly line 3 is about to fail in the next 48 hours. And if we go to the details of it, we can actually see what is the problem. So there is a component failure which has been detected, and we have a maximum life of 2 days, this component. And the interesting thing is you can actually see how to solve this problem. So we have prescriptive solutions which say that you can either replace the bearing, or you can reduce the speed and extend the life of the bearing. So these are little suggestions that have been provided to us by the system, and based on the different manuals that we have, different documents that are available in the system, and it gives you a complete list of how to go ahead with these changes, or what will be the cost impact of these. The beauty of this piece over here is that you don't really have to be an IT guy to understand what is going wrong. It is the simplicity with which this information is available in the dashboard is what makes it accessible to all the users beyond just a certain section. So this is how we can, decision makers can actually detect risks and take timely action. And finally, we have the AI assistant over here, which is like a little highlight that we have added in the dashboard, which gives you information on anything that is available in the data, anything that is not added in the dashboards already, or something that you want to talk to the data with. This is your interface to do that. So as you can see, I have asked questions in simple plain English, like what were my total sales orders for 2024? And it has given me a total list of the number of orders and the total value of the orders. And the interesting part about this section is that it is not just giving you a result, it is also giving you the source of this result, how it is getting to the result. So it has actually referred to all the tables that it has searched and the filters that have been used. So the idea is not just to show a result, the idea is for end users to actually have confidence on the agentic system, that the agent is not just, it is, the results are based on the data that is available in the system. It has not just been pulled out of thin air. So we can see questions like these, and you can actually go ahead and extend your questions to say something like, predict my sales orders for 2026, because then I would have to prepare for it accordingly. And based on my order history, it has given me a total complete analysis, and my 2026 forecast is close to 3,000 orders. So this is the Agentic Command Center demo.
Thank you, Sargam. So what makes this proactive rather than reactive? At what point does the system step in before a human would normally act?
That's a great question, Andy, because a lot of dashboards, they look impressive, but they are still reactive in nature. So in a traditional setup, someone acts only after something has already gone wrong. Either the inventory drops below safety stock, or a supplier misses a shipment, or the production slows down for whatever reason. Here, the system is stepping in earlier. Before a human would normally notice anything going wrong, the platform has already started analyzing the confirmed sales orders, the inventory that is in hand or in transit, or the supplier risk signals even. So when those three start drifting towards imbalance, that is when the system starts raising alerts and it surfaces to the decision makers. So instead of discovering a shortage when the production is already impacted, the system starts raising flags earlier, and it gives time for the people to take timely action. That is how we shift gears from reactive firefighting to maybe proactive intelligence.
Amazing. So behind what we are seeing on screen, how are these different capabilities working together? Sounds like there is a lot going on in the background. So how do they work together to arrive at the recommended course of action?
Absolutely. What you are seeing on the screen, it looks simple, but there are several layers working together behind it. So from the very beginning, the first is the data layer, because the data is continuously ingested from ERP, logistics, supplier systems, all of it into our lakehouse. So that gives us clean, scalable, historical data, which is in real time, but it is all raw data. Next comes the semantic layer, which is the business layer, where we define ontologies, which actually says what is a product, what is a supplier, how supplier risk needs to be calculated, or how the stockout risk is computed. So this is what gives definition to the raw data that we ingested in the first layer. Next is AI, and obviously there is no guessing. This is the operating with. So AI engine runs the stockout prediction using demand, supply, and supplier risk. So that is the AI layer, which is doing all the computing in the background. And finally, you ask a what if question, like we just asked, that predict the sales orders for 2026, which is done on the conversational layer. So this layer is actually interpreting the request that you gave. It is using the ontology to calculate, to decipher what it means, and then it recalculates the prediction using the AI layer, and then it returns an updated updated value. So what we are seeing on the screen is actually a combination of ingestion, lakehouse storage, semantic modeling, predictive AI, and conversational reasoning, all of it orchestrated together. So it's a what looks like a dashboard is actually a coordinated platform flow.
Fascinating. So how does this enable business leaders to operate in a self-service way while still staying within defined business guardrails, right? We don't want everybody to go wild, and then we are adding back in meetings where everybody shows his numbers, their numbers, and nobody knows how it fits together.
Absolutely, and that is exactly where most platforms struggle, because self-service often means chaos. Everybody, like you said, everybody defining their own KPIs differently, they build their own logic, create their own risk. Here in the command center, business users can ask questions in plain English. They can run scenario simulations. They can build low-code applications even. They can drill into the metrics. But all of this happens only all the while they are operating within guardrails. So they cannot actually touch the data in the system. They cannot redefine the ontologies. They cannot change how the agents work. The ontology defines the business structure and relationship. The semantic layer defines the KPIs. The RBAC ensures that you only see what you are supposed to see. So, and everything is auditable all the while. So it is all controlled by the platform security. So the leaders can move quickly with this, yes, but they cannot break the logic, or they cannot redefine the logic in any way, not even accidentally. It is freedom, but within a structure.
So we are still providing order and method to the madness. Thank you, Sargam. So much for agents as partners in the operational world. Let's now dive into the world of R&D and accelerated innovation and look at the case where the decision problem itself is more complex, where the user starts with a goal, multiple constraints, and trade-offs to manage. We will also look into how we build this system, how we arrive at an agentic result. Over to you, Ashutosh.
Thank you, Andy. So I will share my screen and let's deep dive into how we can create these agents. So before we get into the agentic flow and the application, I just quickly wanted to touch upon the use case that we are going to show you. So in this use case, we are going to create the optimized formulations. So we have some of the ingredients using which and some of the property that need to be targeted. And we are going to find the optimal mixture of these ingredients to get to the desired property. So how are we going to do that? We have a master agent which will catch the user intent in the natural language. This master agent is enabled by knowledge graph. So knowledge graph not only provide the context to the master agent, like which all ingredients are present, what are the permitted values of those agents in the history, etc. But it also enforces the guardrail, the constraints, which are very important for any optimization workflow. And then there is a formulation agent, which is going to do the actual AI related work. So it is going to generate the design of experiment. Then it is going to predict using the historical data, and finally optimize and give you the most recommended formulations. So let's go into the interface and see the demo. Okay, so now let's look at the interface of MCube, and this particular module is the agent builder, agentic framework, or agent orchestrator. So here we create the agents. So before we get into the different options which are available to build the agent, let's look at some of the results first. So this is the chat node for rapid prototyping. I'm going to go to the chat node and I will start asking questions. So what is this formulation demo all about? And this is a primary question to our knowledge graph agent, because here we are not invoking any of the AI agents. Basically, we just want to understand what are the ingredients, what are the properties, and so that we can ask subsequent questions as a new scientist or as a new user. So here the master agent is getting the intent from my question, and then it will invoke the subsequent sub agents to get to that answer. So now it says that formulation demo involves experiment with three main ingredients: resin, solvent, and plasticizer. And then there are three output properties: dynamic viscosity, clarity, and tensile strength. So now my next question would be to generate, let's say, 15 experiments, new experiments using design of experiment. So I will say that generate 15 using full factorial. This is one of the method for generating the design of experiment. And if you look at the question, I have not asked anything about or not informed anything about the constraints. So what should be my range of solvent? What should be my range of plasticizer? So that's where knowledge graph agent comes into picture and enforces the guardrail, even if a user will not give it. Now, if I give those information and if I want to override the guardrail, that is still possible, but that will still be limited to certain law of thermodynamics, which is or law of chemistry, basically, which is being again enforced by the knowledge graph agent. So here you see that knowledge graph agent is bringing all the guardrails. What should be my lower limit and upper limit for resin, solvent, and plasticizer, and then my master agent is calling the formulation agent to design 15 new experiments, which you can clearly see here using full factorial method. So this helps us to set up the experiment in my lab. Now, if I say that, okay, I want, if I take first of this experiment and I want to predict the clarity, tensile strength, and viscosity. Now, so I will say predict the properties for the experiment with resin 10%. I'm doing the approximation. Solvent 33%, and plasticizer will be the rest, basically. So now the model, it will invoke the prediction model, and that prediction model will predict the predict different properties such as viscosity and other properties. Now, as a next step, I am going to ask, what is the can you rank 5 top recommendations if I want to maximize the viscosity? So that is going to be my next question. So by the time we are getting the answer to this question, I will quickly show you, because now AI model is being called. Oh, we have already gotten the answer. So here you see that with this particular combination, we get some predicted value for viscosity, clarity, and tensile strength. And now let's say that generate top 5 formulation to maximize the tensile strength and minimize viscosity. So now all the modules will be called basically. So it will call the knowledge graph for information, then it will call the uh, prediction model and optimization model. First it will call the optimization model, and optimization model will internally call the prediction model. So everything is interrelated. Now by the time it will generate, oh, it has already generated, it's quite fast. So it has generated me top 5 ranked formulations for the maximum tensile strength and minimum viscosity, as you can see here. Now let's look at the internal working of this agent, how the agent has been created. Here you will see that there are multiple agentic framework. You can create the agent using either agent development kit or LangGraph. And you can also add your own A2A agent. So if any one of your external agents are hosted using A2A protocol, you can just add it and import it into our workflow and start using it. So that will become part of your agentic mesh or agentic workflow that you are going to create using our MCube application. Now, if I deep dive into the agentic sub workflow, here you will see that we have a knowledge graph agent and a formulation agent, as I was showing in the PPT. And then there are lots of tools. All these tools are being called using MCP protocol. So here you see I have prediction tool, I have DOE generation tool, and I have optimization tool. And if I go to any one of these agents, here you will see that we have the option to plug into any of the model provider and models. So we can use either self-hosted internal model if we want to host our own model in the GPU for data security, or we can connect to any of the external LLM providers. So that's all for this demo. Over to you, Andy.
Thank you, Ashutosh. It's very obvious that a lot was going on while we were chatting with this system. Maybe you could summarize and explain how this formulation system with its agentic nature is different from a traditional non-agentic formulation tool as they exist in the market.
Right, great question. So when we look at the traditional formulation tools, so all of them are mostly workflow driven or step based. So you do this step, then you go to the next step as a scientist. The fundamental difference between this system, agentic system, is that everything is integrated and end to end. As a user, you don't have to go to 5 different interfaces and think about how to operate it. Only one trigger is either your text that you are typing in the window, or it can be voice enabled as well. So as a scientist, you are just interacting with one formless interface, and it is orchestrating internally between multiple agents for specialized for different works, and then it is giving you the final output in a semi-structured format.
So if I understood this example correctly, the scientist begins with a desired outcome rather than raw data, like in many other advanced analytics projects. So how does 5.4 enable the system to respond to that intent and generate ranked formulation options?
Right. So everything starts with scientists expressing a goal to the interface, right? So for example, I said maximize, let's say, tensile strength and minimize viscosity. It goes to the master agent, which interprets the intent. So that master agents need to be very powerful in terms of reasoning, so that it can take the user input, and it's a freehand text, right? So anyone can come and write anything. So that's where it becomes very important to for the agent to interpret that when I am saying maximize tensile and minimize viscosity, I am talking about optimization objective and not about generating new experiments to be done in the lab. So that's how that is the main role of master agent. And here knowledge graph actually plays a very important role, because knowledge graph is the place, knowledge graph agent, where all these different steps are mentioned. So it acts as a brain to the master agent. If you have seen the workflow, it is connected to the master agent.
Right.
So these two is like steps are very important to go further and invoke the formulation and get the work done by the formulation agent.
Okay, so we have seen up to 5 recommended formulations like you asked for. So what determines how these are ranked, and more importantly, how should a scientist interpret those rankings?
Right. So again, ranking is based on the goal that scientist has entered in the chat. Here, I myself said that I want to maximize something and minimize something. So what happens is that like the system, the optimization module, it simulates lots of different possibility. And out for all those possible experiments, it actually call the prediction model. And prediction model, even without doing the experiment, predicts based on the historical data, predicts what should be the viscosity and or the strength or the clarity for these combination of mixtures, right? And in that case, what happens is, so once this all these value comes in, then it's all about filtering and converging towards a better goal. And when I say optimization model, we generally use optimization models such as Bayesian optimizer, or even more complicated like differential evolution or genetic algorithm, which actually works on the principle of mutation. So it has like child, and then it mutates, and it again creates new offspring, and it just drives the entire curve cost function into minimal, like to minimize it. And once it reaches a asymptote, that's where it gives the output back. So those five basically those five formulation that you have seen have minimum cost function, which has been created internally by optimization function.
Thank you. So a very basic change happens here, right? Prediction and optimization are unified within one application rather than run as separate analytical steps. So
Right.
That is the main difference, I think, in experience and in time that you spend to come to the same result. And it might be that the result is even better because there is, in that amount of time, a combination of orchestrated agents can run a lot more simulations than a human being can. So one more time, we are giving, we're leveraging the human for what the human's good at, and we're leveraging the agents for what the agents are sometimes better than us. So thank you so much, Ashutosh. This was a great presentation.
Thank you.
Wow, we really have covered a lot of ground in the last 40 minutes. Let me try at least to summarize what we have seen. We have seen how semantic and agentic technologies transform the way we run operations more reliably and proactively, and how innovation and development of new products can be accelerated by focusing the research and optimizing the necessary experiments to validate results. In both cases, routine steps to analyze data and information are delegated to agents in real time, allowing humans to focus their time on what they do best, setting and driving towards business goals and validating alternatives to come to the best decision. The human in the loop gets presented highly refined information and actionable options to pave the best way forward without getting lost in the minutiae of scanning data from different sources, applying advanced analytics, interpreting those results, integrating them all that information required to make those decisions. So leveraging agents that apply intelligence and reasoning to their respective tasks, orchestrated in workflows, empower humans to enhance their contributions to generating business value, directly impacting the bottom line. MCube 5.4 provides the platform to capture the tremendous business potential the new world of agentic applications presents us with, bridging the gap between proof of concepts and moving to enterprise-class production deployments at unprecedented speed. We can see that the agentic core puts our mantra, reducing time to value for our customers, on steroids. Thank you so much for your attendance. We are looking forward to discussing your opportunities to create business value with MCube, as we have shown today. More information about business cases, customer stories, and our latest technology is available on our website and our monthly newsletter, Pulse of MCube. Please join the ever-growing MCube community by subscribing right away. Let's toast to a bright, value-generating agentic future. I hope to see you all soon.